what's up? Jason here from Unity3D.college. Today we're talking about collections. I'm going to go over a couple different types of collections that you can use in your game projects. We'll talk about some of the differences between arrays and collections, what collections are in general, and I'll show a visual example that shows how things are added and removed from different types of collections. Now, if you want to learn more about this, you can of course read the Microsoft documentation on collections. There's a whole lot of information here, way more than I can fit into this video. You can see it goes on and on and on, but let's just get started. So here I've set up a quick sample of a couple different types of collections and an array. An array isn't really a collection, but it's a good base starting point here. So I'm going to hit play, and we're going to add something to an array. Just hit the add array, and you'll see a little cube up here with a 0 and a 1 and a 2 and a 3 and a 4. And if I hit remove, you'll see that they get removed from the end of the array. Now let's look at the code here and see how this works. So I'll select my array object, and we'll just double click on the array cube. Now I'm also using the dark theme here, so if I get a little mixed up, that's why. It's kind of new to me, but hopefully this is helpful. I know a lot of people had asked for it. So let's take a look at our cube array. This has a prefab reference right here for this cube with text. That's just the cube that was being spawned when I hit the add button. We're adding this new object. It's got a little text on there. You'll see that all in a moment, but this is just the prefab for it. And all of these examples are going to have this same prefab linked in here. Then we have a constant int for our array size, and it's just set to 8. When you create an array, you have to give it a size. So here we needed to pass in an 8, and I just named it to make it really obvious what we were doing there. Now, one of the issues that we're going to run into with an array is that once we've defined a size, we can't easily go beyond that size. We can technically resize the array, but it's not something that's done very often. There are some better alternatives. So let's look at this a little bit deeper now. We've got a private integer for our current cube number. You'll see this in all the other ones as well. This is really just for setting that text, but in the array one, it's doing a little bit of extra work. So let's take a deeper look at our methods now. We've got an add method. Our add method instantiates that prefab, just like I mentioned. So just give it this prefab, creates it, assigns it to this cube. And then on the cube, we call set number. So this cube with text script has a set number script on, or set number method on it. And if I hit F12 to go to it, you'll see that all it really does is find the text mesh pro UI object that's a child of it and set the text to that number. Of course, in a real project, we wouldn't want to just be calling this get component in children. We'd probably want to cache this, but this is just a quick sample, and that's not the focus of this thing. The next thing that we do, just went back to the cube array, is we set the position to the transform position, so that's just the parent, this cube array object's position, plus vector3.right times the current cube number. This is just how they're stacking up, going 1, 2, 3, 4 side by side. We're going offset from the thing's position by right, which is, as you can see, a 1 on the x, times the current cube number, times 1.1 to just add a little spacing. So these parts, not too exciting, just placement and text. The next thing that we do, though, is array specific. In fact, let's add a line here. So here we have this array called cubes, and we're setting the current cube number, which by default is going to be 0 because the default value for an integer is 0. This could also be written, by the way, as current cube number equals 0, but we don't need that there because it's the default. So cubes at index 0, this little square bracket gives us the indexer. So the first one here is going to be set to our cube. So now our first entry in this cubes array is that. And then we set the parent to the transform here. In fact, this could probably be up there just to simplify it a little bit more. This is the part that's actually adding something to an array. Now, I want to show you something else here. Let's add the serialized field attribute here, just to make it visible in the editor. And then you'll see that when I add things, this cubes array is going to start getting values. So let's do that. Jump back over here, hit play, let it recompile real quick. And now you can see our cubes are showing up here. And it's an array with the size of 8, and they're all empty. But if I hit add, you see the first cube just got added in there. And I'll hit add again, another cube, another cube, and another cube, and another cube, and another cube. And another, and let's go on. Let's go, and if I hit add one more time, we didn't get another cube. Instead, we got an error. But before I go into how we fix that, I want to show the removing as well. So let's hit play real quick. We're going to add a couple cubes. So let's add 4 to there. And then let's remove the last one. There you go. You see it went away, and that one went back to none. And we add, and it's going back into there. You can add a couple more and remove a couple. And you can see that these values are just getting filled in with these cubes. Let's look at the remove method again. So the remove method here, we just decrement the current cube number. So just subtract 1 from it. And that's because at the end of add, we're incrementing that cube number. So we want to pull that cube number back down because we're no longer going to use the next one. So imagine we'd inserted at number 0. We've incremented that up to 1. When we remove, we want to remove from 0. So we're just going back down to 0 to do our removal. Then we call, or we actually get the last cube here by calling or passing in the index of the current cube number, which is that last one, and getting it right here from cubes. I said that really weird, but essentially cubes of last cube number is going to be set to this variable right here, which is also, get rid of the word var, make it a little bit more explicit. It's a cube. And then we're setting the cubes array at that point to null. So that's why it's going back to null in the editor. And then we call this last cube play removal. By the way, this is also reused across all of them. And again, not optimized at all, but it just gets the renderer, turns it to red, and then makes it kind of fade away. Just so we get that nice little visual effect. So that's how the array works. But again, remember, when we go to add more, we can't just add. We'd have to actually resize the array. So we'd have to use something like array.resize, relatively slow and just not very common and a little bit clunky. So what are some of the other options? Well, let's dive back in here. And we don't even have to stop running. We have the list as our next one. That's this one right here, using our cube list. And if I add to the list, you see, keep adding and adding and adding and go past 8 and keep going. And I can remove stuff here. I'm just removing a random one. We'll see how this works in just a moment. And I can keep adding, and it just keeps adding on to that end of the list. And I can remove, and if I add again, we're going to get the 13th one right there. But right now, our list only has 4 elements in it. So I've added a whole bunch of things and removed them, but our list actually is just a size of 4 things in it, as opposed to our array that's always got this static size. Now, the way it works, it technically has an array kind of behind there, and it's pre-sized and pre-allocated. So it's not like you're saving space here, but you're not having to go in and resize this thing manually. And in fact, like I said, it kind of pre-grows and pre-sizes in anticipation of you adding more things. So it's not going to resize every time you add a single entry to it. Let's take a look at the code for it, though. Go into our cube list. And here again, we have that same prefab. We have the same current cube number. But on line 8, we're a little bit different. Instead of an array, we're using a list. And we use these little brackets here to determine the type of object that's in the list. A list could be a list of anything. It could be a private list of strings. This could be like our strings. And then this would be just, oops, that's not right, new list of string. This would just be a list of strings that holds just text, a bunch of different text entries. They could be integers. Just change them up to be an int. It could be any object type that we want. Here we're using cube with text again because that's just what we're using for our sample. So we have a list of cubes with text, and then in our add, we do the same thing. We instantiate it, we set the number, we set the position, literally all exactly the same except for the end. So let's just move that up there. And I should have moved all those transform set parents in advance. But let's look here. Line 19 is where it's different. Instead of setting an index or setting a value at an index of cubes, we just call .add, and this is going to add it to the end of our list. So if we go back to the cube array, remember we had to do cubes at this index equals the cube. We no longer have to do that. We just call add, and because the cube or the cubes list is a list of cube with text, it'll just expect a cube with text object, and that's what we're passing in there. And then here we're incrementing this number again. We're only using this number for the text there and the offset. We're not using it for the index or anything else like we were with the array. That was only on the array one. And let's look at our remove random entry. So for remove random entry, we get a new index using random.range from 0 to the cube's count. Now count is going to be the size or the number of entries that are in this list. So if we have 4 things in there, it'll be 4, and we'll get a number between 0 and 3. And then what'll happen is we get the object right here. So we say random cube is equal to cubes at that index. And here we are accessing it a lot like the array, because with a list, we can also use this indexer right here and just get it at any point. So we're getting a random one at that index, and then we're removing it. Notice that with remove, we can actually just pass in the object that we want to remove. So we don't have to find an object by index. We can just have an object that's passed around. Maybe it's an object that they've clicked on, that they've selected, or that's somehow related to them, that we just know which object it is. We can just pass that in instead of picking a random one. Of course, we also have an option, let me just show you this, in the list to do a remove at. So technically, we could also do remove at index right here, and it would just, I did remove all. I meant remove at. There we go. And then this would be the same as this code right here that I've just removed. We just remove it at that index, except now we don't have the actual cube, so we wouldn't be able to play our removal. So we'd still need to get that, which is exactly why I didn't go that route. So let's undo that. But it's important to know that that's there. We can, of course, do remove all. So why don't I show that too? So say we wanted to remove all of the cubes that had a value greater than 5. We could do something like this. We go cubes.remove all, and then we're going to use a lambda statement. So just do t space and then equals greater than to get our lambda. And what's going to happen here is it's going to remove everything that matches this, and it's going to use t as kind of a template for the objects in there. So say t dot, and then we'll have access to all of the properties on here. And let's see, what would be a property that we could use? Well, we could use the name, but I don't want to use the name. Let's go add the index on our cube. So I'm just going to go to the cube with text, and when we set the number, I'm going to make that a public property. So do public int number with a getter and a private setter, because I don't want this being set outside of here. And then when we set it, I'll just say number equals number. Oops, not number, number. There we go. So now I've got an accessible number that I can use to do my filtering. Again, we probably wouldn't filter on just this number. You might filter on things that have health greater than some amount, or are of some type, or have some weapon or something. But say I want to remove all of them where t.number is greater than 3. This would just remove all of those objects. Now, it wouldn't actually clear anything up because we're not playing the cube removal, but we would be removing them actually from the list. Now, if we wanted to get all of these objects from the list that had a number greater than 3, we could actually do something like this. We'll go var cubes greater than 3 equals cubes.where, and then we'd add in a using system.link statement. And then here I'd usually add a toList at the end, but it's not necessarily required. In this case, it wouldn't be. But that just converts it to be an actual list instead of an IEnumerable or queryable that we can go over. So here we're getting a list now of all of the cubes where the number is greater than 3, and I could iterate over those. Do for each var cube in cubes greater than 3, and I could just play the removal right here. So I could copy this, paste that up here, place this with cube. So now we'd loop over each cube in this list of cubes that are greater than 3. In fact, let's spell this out really clearly. We'll call this list of cube with text. So we're creating a new list from these of all the ones greater than 3, and then playing removal on it. And then we could even just say cubes dot, well, yeah, let's just do dot remove all t dot number greater than 3. So now we'd be playing the removal and removing them. In fact, let's comment that out, save, and just see it in action real quick. So stop and replay one more time. And then we'll add some things to the list. And just hit remove. Remember, it's no longer random. It's everything that's greater than 3. Now if I add more things and hit it again, we're going to get the 9, 10, and 11. If I hit it with nothing, we'll just get nothing because there are none greater than 3. So that's a list. Like I said, there are a lot of things that you can do with a list. I only wanted to cover a couple of them, and it's probably the most common thing. Now it's important to also note that if you're using things like link in your code, you want to make sure that you're not generating garbage that's going to need to get cleaned up, especially not massive amounts of it. Depending on your situation, though, it can be really helpful to make nice, simple, fast queries like this. I usually use them for things that are either less common, stuff like initialization, where things are getting found and done really rarely, or on server-side stuff where I'm not so worried about garbage collection because it's running high-end systems with a fast garbage collector. Definitely try to avoid these things on mobile. But lists, still use all that stuff. It's just the link stuff that I'd be a little bit more cautious about on mobile in an update loop. Now I want to talk about queues and stacks, the other two that are right here. So let's hit play and let's watch how these work. So with a queue, we don't add to it exactly the same way. We call enqueue on it, and that just adds an object to it. And you see as I add them, they just get added normally. No different than a list or an array, really. A little different than an array, but no different than a list. And then if I remove something from it, watch, it comes from the beginning. So if I pop it, the queues actually come, it's first in, first out. So the first thing that goes in, the first thing that's enqueued, is the first thing that gets removed when we dequeue. So now if I add some more things here and remove some, you'll see that we still go in the same order. So a queue always pulls the oldest thing out when we request it. Now a stack is kind of the opposite. Let's add a couple things to the stack, and then let's pop from the stack. So the stack actually pulls the most recently added thing to it. Now if I add more things, we get 4, 5, 6. You'll see that 6 is going to get removed first, and then 5, and then 4, and then we go back down to 1, and so on. So a stack is first in, last out. So that means that this one went in first. It's the last thing that'll ever be removed from it. Where a queue is first in, first out. So whatever the oldest thing is, the first added thing, that's the thing that you'll get back. Let's take a real quick look at the code. It's actually pretty simple though. So let's select the queue first. This is the first in, first out version. And here you'll see that in add, we do the same stuff. Just create a prefab, put it in a position, and then we call enqueue because we're not using a list, we're using a queue. So we have to use enqueue to add things to it. Then if we want to remove something from it, I'm using this pop from queue method, it's actually just calling dequeue on it. And this just gets the most recent, or I said the most recent, didn't I? This is a queue. It gets the oldest object. So whatever was there first, whatever was enqueued first, it gets that back out. And then if we look at the stack, you see that it's, again, very similar. Same kind of code, except here we use push instead of enqueue. When we want to push things to the top of the stack, we use push, and then we use pop to pull them right off the stack. Pretty simple, and these are really useful for a couple different things. I generally use them for things like pooling systems, so I'll just take a queue, so that way the oldest one is constantly the one getting recycled, and I'll just put objects that are ready to be used into that queue, and then pull them out when they're done. Also for things like messaging systems, anything where I want stuff to go out in order, and I'm going to have a list of things that are adding up and going back down. One really common case for this is just stacking up messages in an asynchronous thread. So if I've got messages coming from another game or another service, not a game, into my game, and I want to queue those up, I will use a queue for that. So that way they come in, they get queued up in another thread, they're basically added to this queue. Then I'll have another thread that's actually reading them and pulling them off the queue one at a time. Now there are, of course, lots of simpler examples. That's just one that happened to be semi-recent and something that I do quite often. So there is one other type that I haven't talked about yet, and that's this dictionary. Now, I couldn't come up with a really cool example that fit right in here for a dictionary, but they are extremely important and I use them all the time, so I really wanted to cover them. So instead I went with something that's a little bit closer to actual use cases that I have, and I built an item dictionary class. So this is just a mono behavior with a couple things on it. Technically, doesn't even need to be a mono behavior. I'm not using any of the mono behavior stuff, so I could just delete that. And just imagine that this is added by some system that needs to keep track of items. In fact, I have some systems like this for data that gets loaded from a database. So if I pull in all of the items from a database and they're all keyed on an integer, so if they have an integer key in the database for their primary key, which a lot of the cases, what you have an integer key there or something similar. So we have a dictionary here with two types. It has int and item. And let's just delete the comma and hit it again and get the little IntelliSense. You'll see here that we have t key and t value. T key just means it's what type do you want to use for the key. This is the thing that you want to look it up by. It can be an integer, it can be a string, it can be pretty much anything. Just pick an object type and use that. In this case though, an integer just makes sense, like I said, because Just imagine we're mapping to a database that has integer keys, and I want to map 1 to 1 right there. So we have a dictionary of items. We initialize it to a new dictionary of the same thing. It's items with an integer key. Our item class is right here. See, it's very simple. It has an ID, a name, and some damage. Nothing complicated. A real item probably have a whole lot more. And then we have two methods here. We have an add item that I want to look at first. And this just takes an item. And first thing we do is check to see if this dictionary already contains a key with this item's ID. So imagine we're adding item number 5. We want to check to make sure that this dictionary doesn't already have an item with a key of 5, because when we go to look up and find item ID 5, well, we wouldn't know which one to get if there were multiple. Of course, if we want to do multiple, I'll show you how we can do that in just a moment. Now, if we don't have an error there, we skip past this error message and instead go into the else statement, and we add it, and we've noticed that we pass in an ID. So this first parameter here is the integer, and the second parameter is the actual object. In this case, because it makes sense for it, I'm actually just passing in the item's ID and the item. Now you might think, well, why not just have a list of items and then find the one by ID? It's essentially what we have here, except that it's a lot faster. The dictionary is a much quicker lookup than looping through the list or using link or something to find an item in the list by ID. So here we just have a really fast lookup of items. So if we call get item and pass in an ID, we can almost instantly get back the correct item. And it's already there. It's already it's already just optimized for reading, basically, is what I'm trying to get across. So what if you had something else? Maybe you wanted to have an integer, and this isn't an item ID, and instead you want to do it by like a item type. So maybe we had a public. Let's do it as a full enum. Let's do this. Let's go public enum item type, and we have like a weapon and maybe armor. And you can imagine we'd have 30 of these, however many. Then we'd have in our item a public item type called item type, and then we wanted to group these by item type. Instead, what I would do here is change this. I'd first rename this because I want it to be very clear and specific. So I'd call this like items by item type. And then we'd change this to item type. And we change this one to item type. So now item type would be the key. But we still have some errors. Get item would need to take item type. And this would be named item type again. Just change it all up, right? And then, add item would stay the same. So then in our contains, we would look up by item type, this lowercase one, and we'd return the one back that was of that type. And here we'd add the item type. And don't worry, this isn't pointless. We're going to go over it, why we're doing this in just a moment. And then here we'd add by item type, this item. Cool, but then we could only have one armor and one weapon, right? The nice thing here is that we can actually mix these collections up. So say I wanted to have a dictionary that showed all of the items by item type. I could change my dictionary to have its value type here actually be another collection. So you say list of item. And then I copy that here and put it here. So now we have a dictionary by item type as the key. So it's going to be weapon or armor. And it's going to have a list of all of the items that match that type in the entry. So now this is no longer accurate. We can't return back a single item because we're getting items that are in a list. So I'd change this to something like list of item, and I'd rename it to get items because it's returning more than one. And now it's going to return back that whole list of all of the items of that type. Then when I add an item, well, I need to change my contains statement a little bit here, because now I no longer have just an entry for each thing. I have an entry for each type. So I need to, before I add an item to this entry for the type, I need to make sure that there's actually a dictionary entry there. So the way that we do this is say if items by type contains key item.item type, so this is if it contains weapon or armor, whatever it is, and I want to say is false. So if it doesn't contain one of those, then I want to do something. I want to add an entry here. So just clear all this out. Don't worry, we'll refactor that in just a moment. I'd copy this and paste and just say .add. So I want to add a new entry, and we use the item type from the item. So just do item.item type. And then the value here needs to be a new list. So I say new, and just kind of let it autocomplete for me, and get a new list of items. So this is just going to say, hey, if we don't have a list of items for this item type, go ahead and create it, new it up, get it ready. because the next thing we're going to do is say items, oops, not the square bracket, items by type, item.item type. So this is that list. This is going to get me that list right there. In fact, I could even say var list equals that, and just this is going to be a list of item. And then I could say list.add item. That's it. So now we'd be adding items to the list here, and when we call get items, we'd be able to get back all of the items of that type. Of course, we could also just get rid of this creation of the variable there and just call it like this, and it would work as well. So works fine either way. Just kind of wanted to show it there. So again, dictionaries are one of the most commonly used things, at least in a lot of my projects, dictionaries and lists. Queues and stacks tend to get used for more specific cases like pooling or messaging, but there are some other things. If I just have a list of things that need to be done in an order, a lot of the time I'll just go with a queue or a stack if I always want it to be that same order. If I want to kind of get things randomly, I'll go with something like a list or a dictionary maybe. And if things are not going to change, if the size isn't going to vary at all and it's going to be the same, then a lot of time I'll just use an array because it's the lightest weight, simplest solution. Anyway, thanks for watching. Don't forget to check out that Microsoft documentation on all of the other types of collections available to you, and just try these things out in your projects and see where they fit and how they work. Thanks for watching again. Don't forget to like, subscribe, share with all your friends and all that stuff, and bye.